What up?
Hi there.
What up?
How you doing?
We doing good.
Yeah. Video number 5.
Cinco.
Moles and Stoich. Here we go.
Measuring moles using gram formula mass. What?
Yeah, new task. New task.
Math involved.
But let's be honest, this one ain't bad, but you got to get it right every time. Let's get to it.
As a chemist, this was a very, very important thing to me when I was doing reactions at Kodak. And how about you?
Not so much.
Not as much?
I actually use this a lot when I was making solutions for us for lab. This is
Right.
I would go back and actually really go through what we learned here and use it, and it would come out good.
I used a different aspect of it to predict the outcomes of chemical reactions in a lab, and it worked. It was fun.
Yeah.
So a chemist can't count molecules of atoms without relating the mass of it to a mole. We can't count. They're too small. We have to use a scale.
Yeah, this is a cool little shortcut we use, and we use molar mass to do it.
So we can count things by weighing them.
Yeah. And really, molar mass, and just so you guys know, maybe a little side note, gram formula mass, it's all the same thing.
Yeah, molar mass, gram formula mass, there's 3 synonyms of the same concept. How much does 1 mole of a substance weigh on a scale?
Right. So, the coefficients in these
Balanced chemical equations.
generally mean moles.
Not grams.
That's the only rule, is they can actually mean anything but grams. They can actually mean molecules or atoms or particles.
Can't mean grams.
No, because we don't have a way to get from one to another, atoms wise to grams that easy. We've got to use moles to get there. So
Right. So when I'm looking at a formula, I see numbers in front of formulas. That's the number of moles.
correct. And you'll see.
But we don't know the number of grams, so we have to use this concept to convert the moles given to us in these balanced equations to the grams that we'd have to use if we were actually to do it in the laboratory setting.
Right, like how much does 4 moles of carbon actually weigh? We actually can tell you before we mass it.
And then we can check it, and that's where the percent error stuff comes in.
Right.
So it's all spiraling together.
Here we go. So technique for calculating gram formula mass.
There it is. What
Easy
do we do?
peasy. You run us through the technique, and I'll pick up a pen.
Sure. So first thing you always have to do is we have to count the numbers of atoms present.
Okay, so I see in this first one, I see Na and I see F. I'm going to go ahead and write those.
Yep.
And how many NAs, Mr. Monaco?
There's no subscript after Na, so we assume it's a 1.
Okay, so I have 1 Na and I have 1 F.
I agree.
All right, counting atoms done.
Next. Now we got to multiply the number of atoms by that atom's mass on the periodic table. It's atomic mass. So put a little multiplication sign there. Boop, boop. And we look up sodium on the periodic table, and I see in our notes here 22.989.
Ooh, that 0.989, that's really close to 1. Let me round that up.
Sure.
Cool.
So what are you going to do? 22, 23. Perfect. I'm cool with rounding to the nearest whole number.
So
Unless I specifically tell you otherwise, you can round to the whole
Yeah,
number.
but let's not write 22 there, because that is going to get you dinged.
Yes. 22.9 acceptable, 23 acceptable. Don't write just 22.
Correct, please.
Now, we got to do that for fluorine too. And fluorine's atomic mass is 18.9984.
I'm going to call that 19. Is that cool?
I'm cool with that too.
All
Because
right.
again, either 18.99 or 18.9 or 19, we good. So
All
we
right,
have
so
2
do that.
numbers. What do I do with these 2 numbers? Well,
Step 3.
add the total masses of the constituent elements to find out what the whole compound would weigh. And 23 plus 19 is 43, 52.
42?
52. 42. 42. You got me, Mr. Milks. He is better at math.
We're not
than I
arguing
am.
about this one. We're not arguing
No,
about
no, no.
this.
And the last thing you'd want to do is put a unit, grams per mole. G
Grams per mole.
per mole, M-O-L. And what this means is that 1 mole of sodium fluoride, NaF, would weigh on my scale 42 grams. It would have Avogadro's number of formula units in it. And that would be how you weigh this in the lab if I had to do a reaction that says you need to react 2 moles of sodium fluoride with water. Well, you'd figure out how much 1 mole weighs, multiply that by 2 and say, oh, I got to go weigh out 84 grams of this stuff and mix it with water. So we're going to do one more, or am I going to do one?
I'm going to do this tough one because this has to do with counting atoms inside the parentheses.
Right.
We definitely need practice on that.
Mhm.
Statement for him and I, though, real quick.
Yep.
If you have you do written on your paper, you don't be getting credit. That
Yeah.
means you actually do them.
You need to do them, just like we're showing you here. So
All right,
first
so
thing, always,
how many
count up
count
the
these?
atoms of each element and compound. Calcium,
How many?
1. No subscript after calcium.
Okay.
Nitrogen, 2. We distributed the 2 from the parentheses back into what's within the parentheses to count the atoms.
One.
Was 1, now
There's
it's 2. Oxygen, 6. 6 moles of oxygen atoms in 1 mole of calcium nitrate. And we're going to multiply by the mass of that element off the periodic table. Calcium is just straight up 40.
Straight up 40. That's good.
40.08. We're going to round. Okay.
I'm good with that.
Nitrogen's 14.00, so we'll go 14 times 2, 28. Oxygen's 15.999, so we'll go 16. 16 times 6, I think it's 96. That's one that we run into all the time.
Right?
And then you add these
14.
3 results together.
So it's 164.
And the units. Sloppy.
164 grams per mole.
Grams per mole. And what this really means to the chemist in the lab is if you need 1 mole of calcium nitrate, you weigh on the scale 164 grams.
Right.
Since every element has a different atomic mass, every mole of every different compound is going to have a different mass per mole.
Kind of like a fingerprint almost.
Every formula has a different formula mass.
Right.
It's a different formula. Yep. And so we weigh a different amount per mole on the scale. And that's how we, in the lab, in the research facility, make sure we use the right number of atoms in our ratios.
Right. Now, just a real quick go over. We need to be able to count atoms. We learned how to do this in a previous video. Notice it's coming back up.
Yep.
We did say in that video you need to get it right every time.
Yep.
Here's exactly why. If I put a 2 in that calcium in example 4, because I distributed the 2 outside the parentheses.
Too far, if you went too far back, your answer would be 40 grams too heavy.
Right.
It would be 204 grams per mole.
Sure.
You'd weigh that out, do the reaction, and maybe it would go out of control because you used too much.
And then, so now when we master this step that we need to be able to get right every time, we're going to use this in a future homework video. So these steps are going to compound. So when we say you need to get them right every time, we mean
We
it.
really do. So let's see what else we got here. Page 13 and 14, some practice and a Google homework on the form. So that's what's up with this.
Menu out.
Thanks. Stop recording. Stop recording.